Okay. In today's session, we are going to discuss about potable water, its specifications and treatment. It is the most important topic in this water and its treatment. Potable water is nothing but water which fit for drinking is called potable water. So it is used for the human consumption. The water sample which is used for human consumption is called potable water. Here, potable water, some specifications, some important characteristics should be followed, then only that will fit for drinking purpose. So these are given by specifications of potable water are given by World Health Organization, which is called WHO, and Indian Standards of Drinking Water. According to these two organizations, here we are discussing some of the important characteristics which should be satisfied in order to consume water for drinking. According to these two organizations, water should be clear and odorless, pleasant to taste. So there is no color and no smell should be present, and it should be so permeable and pleasant to taste. Okay. Hardness should not exceed 125 ppm. According to WHO and World Indian Standards of Drinking, it should not exceed 125 ppm of hardness, and pH should be almost neutral, and slightly basic conditions are preferable. In the range of 7 to 8.5 ppm, pH is preferable for this is preferable for drinking purpose. Almost neutral pH should be maintained in order to consume as a drinking water or potable water. And dissolved solids in the sense any kind of materials which are water soluble, that is called total dissolved solid content. The total dissolved solid content in the potable water should not exceed 500 ppm. Up to 500 ppm it is permeable. If more than 500 ppm is there, that water sample is not fit for drinking. And next is about turbidity. Turbidity is nothing but any solid material or any precipitated matter or coagulated matter present at the bottom, or any turbid things present in water, all those comes under turbidity. So that should be less than 25 ppm. So water should be clear. That's why turbidity should less than 25 ppm. Free from heavy metals. If any toxic metals like lead, arsenic, chromium, manganese present, that water is not fit for drinking, and those causes so many hazardous and toxic effects in our body. So that's why water should be free from toxic metals, especially these mentioned lead, arsenic, and so these metals should be, these metals should not be present in the drinking water. And next is about water should be free from pathogenic microorganisms like bacteria, virus, fungi, algae, and protozoans. If those microorganisms present in the water, that causes so many impacts or health problems, those are called waterborne diseases. That's why the important thing is water should be sterilized and free from pathogenic or disease causing microorganisms. And there should be there dihydrogen sulfide, carbon dioxide, ammonia. When these gases present in water, again this water is not fit for drinking. That's why potable water should be free from these dissolved gases. These are the important specifications given by World Health Organization and Indian Standards of Drinking. So water, when maintain all these conditions, then it is fit for drinking. Now let us see what are the important steps involved in the potable water treatment. So potable water treatment is a multi-step process where first we are purifying water, and the next second step is sterilization or disinfection. Sterilization is nothing but removing all disease causing organisms from the water sample by means of different process are possible, that is called disinfection or sterilization. Let us go one by one. Screening is nothing but simple removal of impurities which are floating on the surface, otherwise any solid impurities present in the water. Simply we can say it is the filtration of large objects from the water by passing through screens. Any metallic screens can be used, bar screens and mesh screen, two kinds we are applying in order to remove all the solid impurities from the water. And second is about aeration. Aeration is nothing but exchange of gases are possible. Water is allowed to pass through the cool fresh air. When we are passing cool fresh air, what happens? Exchange of gases, whatever hazardous gases present in the water like H2S, carbon dioxide, ammonia and chlorine, they exchanged with oxygen. This oxygen is mainly used to improve the quality of water sample. Greater the dissolved oxygen content, greater will be the quality of water. So that aeration is very important in order to exchange the poisonous gases with oxygen. So this is the second step. In the third step, coagulation. Coagulation is nothing but any semi-solid impurities or any colloidal sized impurities are present in the water. They may not be precipitated by natural gravitational force. In that condition, we need to add coagulating agents or chemical substances which enhance the rate of coagulation process. Some of the coagulating agents are alums. Alum is nothing but potassium aluminium sulfate 12H2O and sodium aluminate. This is another coagulating agent. Coagulating agent is nothing but which used to precipitate semi-solid particles or colloidal sized particles. And even aluminium sulfate is also added. Most of the aluminium components are working like coagulating agents. What they will do means, so when these coagulating agents are added, they used to aggregate all semi-solid particles so that they get easily precipitated. For example, when this aluminium sulfate is added to water, any calcium bicarbonate solid is there in water, what happens? That is converted into precipitate of calcium sulfate and aluminium hydroxide. In this way, water containing any semi-solid or colloidal sized impurities, they get precipitated or coagulated or fluctuated by this coagulating agents. Alums, sodium aluminate, sodium sulfate are the better examples for coagulating agents. And next is about filtration. After getting precipitate at the bottom of the huge tank of potable water, we need to remove all the solid impurities present in the water by simple filtration process. For that purpose, we are using sand as a better efficient ancient filtering agent. In this, we are taking three layers of sand. One is what gravel layer, second is coarse sand layer, third is fine sand layer. Fine sand layer and second is about coarse sand layer, third is about gravel layer. By using these different sized, different diameters of sand, different particles of solid impurities present in the water can be discarded. So this is the efficient method for the removal of solid impurities by simple filtration using sand bed filtration, where adsorption is the important phenomenon in this. By that adsorption process, impurities gathered and removed from sand filtration. And colloidal impurities, when present, those colloidal impurities also removed by using this sand bed filtration. This is a schematic representation of sand filtering method. Raw water entered into this and fine sand, gravel sand will be there. And this what sand layer used to absorb all the turbid matter present in the water, so that clear water is coming out for the distribution. And next is about disinfection. It is the important step involved in this potable water treatment, because most of the diseases all around the world are mainly caused by contaminated water only. That's the reason why sterilization or disinfection is the important step before consumption by any living organisms. So that's why disinfection process we are going to discuss. Disinfection is carried in so many diverse routes. Among all, the first important one is by boiling process. When we are heating water at 100 degrees centigrade for only 20 minutes, so time duration should be fixed, because if we are heating continuously, even dissolved oxygen, which is important for the survival, so quality of water, that is also evaporated. That's why less than 20 minutes heating or boiling is required at 100 degrees centigrade. Temperature should be maintained at 100 only. So at this temperature, all the micro or pathogenic organisms are not able to survive. That's why all can be easily removed from that water. So it is a simple and efficient method of water sterilization by boiling for 20 minutes. So since while boiling process, all kind of pathogens, not only bacteria, protozoans, any disease causing organisms present in the water can be removed. And second is about ozone treatment. It is most efficient treatment among all the described methods, because when we are going with ozone treatment, ozone is highly unstable material and easily converted into molecular oxygen and nascent oxygen. Molecular oxygen used to improve the quality of water by improving dissolved oxygen content DO. And second is nascent oxygen. This released nascent oxygen will kill pathogenic organisms present in the water sample. And the next is about schematic representation of this ozone treatment. Water sample is allowed to pass through this ozone generator. ORP probe will be provided, and even UV light is also irradiated along with ozone treatment. Ozone injection is possible into water, and these are used as a filters which used to remove all the solid impurities present in the water, and whatever solid impurities are what collected, those are discarded to drain. So this is about the ozone treatment in potable water. Next is about what are the disadvantages of this ozone treatment. Ozone treatment cannot be applied in the large scale because ozone what storage and transportation is somewhat difficult, because it is highly unstable, and it is somewhat expensive also, because ozone is not freely available. Synthesis is expensive method. Hence restricted applications we have for ozone. Even closed compact regions, wherever cinema halls are closed, huge mass gathering in what where any shopping malls are, and even swimming pools in that region, also treatment of water as well as air is possible by using this ozone. It is more efficient, but only the drawback is it is a expensive method, and a large scale we can't apply because ozone is not freely available in nature. It readily converted into molecular oxygen. And second is about chlorination. It is a widely used method for the sterilization. So we have different methods of chlorination by passing direct to chlorine gas. So water is irradiated with chlorine gas. When chlorine gas added to water, it immediately hydrolyzed or dissociated into hypochlorous acid and HCl. Hypochlorous acid again dissociated into HCl and nascent oxygen. Again, already we know nascent oxygen is mainly used to kill the pathogenic organisms. So in this way, even chlorine is also generating nascent oxygen. That's the reason why it is also more efficient. But the drawback is when chlorine directly passed, it will change the order and it will cause the corrosive effect in our sensitive tissue when administered if it is in higher concentration. That's why direct to chlorine gas passage should be avoided, and even generate acidic medium. Liberation of acids are possible. That's why it is not preferable direct passing of chlorine gas into the water. And second is about addition of chloramines. when ammonia when ammonia is added with chlorine gas, ammonia is added with chlorine gas, what happens, that used to release ClNH2. This is called chloramine. This chloramine when added to water, it is converted into HOCl, again hypochlorous acid, which is responsible to kill the pathogenic organisms. So chloramines are somewhat lesser what corrosive in nature, and these agents are very readily releasing hypochlorous acid into water, so these are used to kill the pathogenic or any disease causing organisms present in the water. And next is about most important and ancient and the simplest and widely used method is addition of bleaching powder. Bleaching powder chemical formula is CaClO2. So this is called calcium hypochlorite. Chemical name of bleaching powder is calcium hypochlorite, CaClO2. So it is the widely used disinfecting agent. So how it works, let us see. When we are taking this bleaching powder, when added to water, it releases calcium hydroxide and chlorine. So whatever acids they're generating in chlorine hydrolysis can be neutralized by this calcium hydroxide base. That's the reason why it is more efficient compared to direct chlorination process, where calcium hydroxide is the base, and in this chlorine hydrolysis it is releasing hypochlorous acid as well as HCl. This HCl and the calcium hydroxide both are used to neutralize the system. So, and this HOCl released, which is called hypochlorous acid, used to kill the pathogenic microorganisms, because hypochlorous acid dissociated into nascent oxygen and HCl. So, this nascent oxygen will kill pathogenic organisms. Now, let us discuss about the most important topic in this chlorination process is called breakpoint chlorination. Breakpoint chlorination have additive advantages compared to remaining all kind of sterilization methods, because 100% sterilization is possible. Whatever pathogens present in the water sample can be removed by this breakpoint chlorination. So that's why it is very important. A separate question is also given on this breakpoint chlorination also. That's the reason why we are discussing this, we are stressing this breakpoint chlorination. So let us define this. Breakpoint chlorination is nothing but amount of chlorine which required to kill the pathogens or kill the bacteria, and also to remove any organic matter present in the water. Remaining all the methods only uh, r- used for the removal of pathogenic organisms or sterilization process only. But additionally, breakpoint chlorination is nothing but amount of chlorine which required for killing of pathogens, as well as any solid impurities, any organic impurities present in the water. So additional application is there for this breakpoint chlorination. That's why it is more significant in nature. Okay. So in this, what we have to do, so estimated amount of chlorine should be added. That chlorine have different function, multiple actions will be there, which are represented in this graph. Here we are plotting the graph between chlorine added on the x coordinate and residual chlorine on y coordinate. We will get different segments, and one curvature is obtained in this breakpoint chlorination. Okay, stage 1 is called A, stage 2 is called B segment, stage 3 is called C segment, stage 4 is called D segment. Okay, so where stage 1 we are discussing, stage 1 we are taking. So this is considered as A part or A fragment, where chlorine is mainly used to reduce the impurities. So any organic matter is there, that organic matter reducing impurities when present, those kind of materials can be oxidized by this first segment or first part. Let us go to second segment or stage 2, where chlorine is mainly used to convert all ammonia and amine related impurities into chloramines. Again, these chloramines are efficient for the disinfection process. That's why second part, what happens, any amine and ammonia related impurities present in the water, all those get converted into chloramines. That is the second segment. And third is about stage 3, where C grams of chlorine is used for the disinfection of bacteria and all other pathogenic organisms. So all disease causing organisms are killed in this stage 3 process, where C grams of chlorine is required for this sterilization process. In stage 4, what happens? The chlorine which is present is called excess of chlorine, that is unreacted chlorine. That unreacted chlorine coming out in this stage 4 is called residual chlorine, which is excess quantity only. So, okay. So up to this, what we are doing, stage 1, we are oxidizing reducible impurities. In stage 2, any ammonia and its related impurities get converted into chloramines. Stage 3, disinfection or sterilization by killing all pathogenic organisms. So up to this, chlorine is utilized. A grams, B grams and C grams of chlorine is utilized. Hence this is called breakpoint chlorination. Up to this level, it is called breakpoint chlorination. And whatever chlorine coming out after this breakpoint chlorination, that is called the amount of chlorine which is coming out is called residual chlorine. So this is an important graph which used to represent this breakpoint chlorination. So that's why it is more advantageous compared to remaining. Let us discuss what are the advantages of this breakpoint chlorination. It used to avoid any bad taste present in the water sample, and color can be destroyed. Chlorine is decolorizing agent and oxidizes completely organic impurities present in the water, and used to remove ammonia and related impurities present in the water. And whatever pathogens are present, all are removed 100%, all are removed with 100% efficiency. irrespective of special type of bacteria, virus, all kind of pathogens can be removed by this chlorination process. It prevents the growth of any weeds in water. If water stored for longer time, what happens? There is a growth of any unwanted plant material, or algal blooms are also possible. This chlorination is also used to avoid or prevent such kind of weeds, growth of weeds in that water sample. And it is more effective and economical because it is a cheap cost material and stored for longer time. That's why it is cost effective. And high and low concentration it can be used. So even at high concentration and low concentration this can be applied. So this is about potable water treatment. It is most